Imagine this, a small chip that gives us superpowers to reveal the composition of material using light. Sounds like sci-fi? Well, let me take you on a journey.
We use our eyes every day to understand the universe surrounding us. From the visible light reaching our eyes, we can understand the colors, shape and texture of objects. And then there is light that we cannot see. The invisible light, like near-infrared radiation that our sensors use. And this can be used to determine the material's composition, such as plastics, food, drugs, and of many other things.
Light is all around us, and it is composed of many different colors. We call these colors wavelengths. These are nanoscopic ripples of light swinging through space. Water droplets, or a glass prism forming a rainbow, show how it's possible to divide a light stream into its constituent wavelengths. And based on this principle, a few centuries ago, mankind has invented instruments that can collect light, break it apart in its wavelengths, and extract valuable information from each of them.
These instruments are called spectrometers. They measure the so-called spectrum of light. This is a list of all the wavelengths present in a beam of light, either reflected or emitted by an object. Spectrometers are used everywhere, from studying stars and exoplanets in long-distant galaxies to the bioanalysis of microscopic particles.
So, spectrometers are currently used in a wide range of industries. For example, process control, recycling, food, agriculture, pharmaceuticals, and many more. However, they are quite large, expensive, and contain many fragile components that require complex alignment and periodic calibration.
While we were doing research at Eindhoven University of Technology, we started wondering how can we transform these large instruments into tiny sensors. We wanted to make this piece of technology available for everybody, squeezing their dimensions to fit into mobile devices such as smartphones or smartwatches.
It's actually really interesting when we look back, because at first we have developed this nice microspectrometer based on 2 nanomembranes moving with nanometer precision, but the device was too complex and fragile. When we started to better explore the potential application and the real market requirements, we discovered what we really needed.
We needed something that is more similar to our eyes and less similar to a lab instrument. For example, with the 3 color receptors in our eyes, the red, green and blue cones, we can already determine if a fruit is ripe or not, but we cannot say how much sugar it contains. And then we came across this tiny animal, the mantis shrimp, which has great abilities, and one of them is a multi-wavelength supervision.
Mantis Spectra's ChipSense technology uses a similar principle. Similar to the mantis shrimp's eyes, our photonic chip of just 1 square millimeter contains 16 pixels that act as photoreceptors. Each pixel is sensitive to a different range of wavelengths in the near-infrared, where all the important chemical information is encoded.
In the past few years, we worked very hard to integrate everything onto a semiconductor wafer that can be produced using an industrial fabrication process.
In order to use this chip, we have also developed a fully portable and standalone unit that has everything in it. The spectral sensor, the light source, the collection optics, and also the high-precision electronics for control and readout. We call it the SpectraPod, and a lot of our customers are using it to collect data from real samples.
The concept behind SpectraPod is simple. First, we shine infrared light on an object. Then, we measure the reflected light using our detectors. And finally, we apply machine learning algorithms to get the chemical fingerprint of the object. Once a machine learning algorithm is realized, our method provides a fast, non-destructive, but most importantly, cost-effective way to measure material properties. We don't need bulky instruments anymore, and we also don't need to send samples to the lab.
With so many applications, it's hard not to be enthusiastic, whether it's analyzing drinks and food, classifying material for recycling and production, or bringing intelligence to home appliances. Our ChipSense technology is the solution. We are so excited that our sensor will be used in so many applications. even the one that we cannot imagine today. The Spectral Revolution has just started, and you can be part of it. We are Multispectral.